Very few minutes that we actually had last time, we introduced the idea of what complex numbers are. And all right, what are complex numbers? Complex numbers are what you get if you invent some new number I, the imaginary unit. And the whole reason to invent this new fake number, this imaginary number I, is that this new number is a square root for -1. And our motivation for doing that is we want to create a new place where more quadratics have solutions. You've seen that when you use like the quadratic formula to complete the square, you might wind up with a negative under a square root. So you want to be able to just handle that. So you create a new imaginary unit if you like. This is page 54 in the notes, not the new notes that I just handed out. Sorry, we haven't started on those notes today. I just wanted to get them out today since I won't be able to hand them out tomorrow. A complex number is anything that looks like A plus complex unit I times B with A and B real numbers. So things like 4 plus 7i, 8 plus 6i. And if these are numbers, well, here are the things you should be able to do with numbers. You should be able to add and subtract numbers from each other. You should be able to multiply numbers. You should be able to divide numbers by each other as long as you don't divide by 0. So what we're going to do on this page is just establish the algebraic properties of the complex numbers. And addition is easy enough. Let's do addition first. And I think it's easiest to do it by just convincing you already know what it should be. 7 plus 2i plus, 5 plus 6i. If you want to see that, how would you want to, what would you want that result of addition to be? Or how would you want to get it? Yeah. Let's get similar numbers next to each other. Whatever addition is, it should commute. You should be able to rearrange the order of addition, and it should give the same result. So you should be able to write that as 7 plus 5 plus 2 plus 6. And you know what? Let's factor out that I. Nice. And now we know everything. What's 7 plus 5? 2 plus 6. There you go. That's how you add numbers. If you want to add two numbers together, just add the real bits and add the imaginary bits. If you want to subtract, do the same. Seem pretty okay? If you want to multiply complex numbers together, well, here's all you need to know. You need to know that I squared is equal to -1, and you need to remember that whenever you multiply a binomial by a binomial, where binomial is just a fancy word for thing plus thing, you have to FOIL it out. So let's see that in practice. We'll write down a formula here in a second, but let's jump right down to this example. 4 plus 3i times 2 minus 2i. So in order to multiply, we'll FOIL this out, and then we'll use that I squared as -1. So let's start by FOILing. So when you FOIL it out, first is 8 plus outside minus 8i plus inside plus 6i last. 3 and a -2 is minus 6. I by I is I squared. I did that correctly? Cool. So there's step one, FOIL it out. The second bit is to use that I squared as -1. So let's look at this term. Minus 6i squared. So that'll be the same as minus 6 times -1. Because remember, I squared is -1. Minus 6 times -1 is plus 6? Yes. Excellent.
So you can rewrite this as 8, may as well combine these together, minus 2I, minus 6, so plus 6.
That feel pretty okay? Nice. So, I think I want to pause for a moment and have you
do 2 examples on your own just to make sure ideas are cemented. How about this? 2 plus 3I times 1 plus 4I. And you know what? That's good enough. Compute that for me.
Tell me what you get.
And once you have it computed, compare with those around you. Pull this up.
Cool. What are people getting?
Negative 10 plus 11.
Negative 10 plus 11i. Is that in agreement? Cool. And just in order to emphasize that chances are your handheld calculators don't have a built-in functionality of complex arithmetic, but it's not like you can't implement this on a machine. It's not like that hasn't been done. You can check your answers. I do encourage you to do that. No reason to ever answer a question wrong. Nice. So, we know how to add. You just add term-wise. We know how to multiply. You have to FOIL. Division. Let's talk about how to divide. So, how to do complex division. So here's the idea. Here's something that would be nice to be able to compute. 1 plus I divided by 3 minus 2I. If that's still a complex number, we should be able to put it in that form, a number plus a number times I. Well, we need like a way to do that division. And here's roughly the motivation for the plan. If I just asked you to compute like, that's an easier thing to compute. Division distributes over addition. So this should be the same as that. So if we could get that denominator to become a real number, we could distribute and then we'd know the answer. Let's think about how to do that. Let's discover a way to do that. That way will come in the language of this thing called the complex conjugate. And we'll see what the complex conjugate does in a moment. So the complex conjugate of any number, which will be indicated by just drawing a line on top of it, a plus ib, the complex conjugate, is a minus ib. So the complex conjugate of a complex number is just what you get if you take the imaginary part and change the sign in front of it. That seems sensible? I mean, does what that says say sense, I guess? Makes sense, not why to do it. We'll see why to do it in a second. So here's the why to do it.
Let's compute this example. 4 plus 3i times the complex conjugate of 4 plus 3i. So let's write out what this is going to be equal to. This will be 4 plus 3i times, what's the complex conjugate of 4 plus 3i? Yeah, just say it louder. Yeah, complex conjugate just means take the imaginary bit and make it negative. Or if it were negative, then you would make it positive.
All right, well, there's still like two things multiplied together right there, right? How do you multiply together complex numbers? You like FOIL that out, right? So, maybe I'll even do this. Multiply those two things together. Tell me what you get. Compare with those around you when you have a thing. Cool. Folks feel confident in an answer? What you getting? Yeah?
25.
I hear 25. Folks agree? Nice.
So, because the computation is somehow good to motivate, I'm going to fill in the steps. So, how did you do that? You, distributed, right? You FOILed it out. 4 times 4 is 16. Outside, minus 12i plus 12i for the 3 times 4. 3 times minus 3 is minus 9. I squared, so it becomes plus 9. And here's the whole point of multiplying a thing by its own conjugate.
Those two things will always cancel. It didn't matter that it was 3 and 4.
Those two bits will cancel, leaving you with 16 plus 9, or 25.
In general, here's the point about multiplying a number by its conjugate.
A number times its conjugate will always be a real number.
And in fact, it'll be a particular real number.
What was special about this 25? It was 16 plus 9. The 16 came from 4 times 4. The 9 came from 3 times 3. In general, a plus ib times the complex conjugate of a plus ib is always a squared plus b squared.
And you don't need to remember that fact, because if you ever do it, you can just recompute the complex conjugate. But it'll let you bypass some computations.
All right, so what's the point? If you multiply a number by its conjugate, you turn that thing into a real number.
We saw that if you were dividing a complex number by a real number, the division would be easy. So let's put those two facts together. Whenever you want to divide a complex number by a complex number, if you want to multiply the denominator by its complex conjugate, the denominator would become real. But you can't just multiply the denominator by a number, you have to multiply and divide. But that's like a full plan now. Let's see it in practice.
If you want to compute this, you should multiply and divide by the complex conjugate of the denominator. So it's multiply and divide by 3 plus 2i, see what happens. So this should be the same thing as 1 plus I, 3 plus 2i, divided by 3 minus 2i, 3 plus 2i.
And let's just compute the top and bottom and see what it gives. original plan was to talk through it, but it looks like everyone's just in the process of doing now, which is great. All right, well, let's go through it. So step one is you have to FOIL out each of these thing times thing. So let's work out what those are.
You distribute out the numerator, you'll get 3 plus 2i. Outside, inside, plus 3i. Last, I times I will give -1, and there's a 2, minus 2.
All right, and you FOIL out the denominator, what do you wind up with? Yeah. Well, let's do it.
3 times 3 is? Three times 2i. -2i times 3. -2i times 2i. Well, -4i squared is what you mean. You said x instead of I. Anyway, cool. Plus 4. Groovy.
All right,
And 6's cancel because they have to.
in fact, how many people just wrote down 9 plus 4 without doing any work? Yeah, of course. It's always a squared plus b squared. That's the whole point of multiplying a number by its conjugate. So you could have skipped some of that arithmetic.
I could have skipped some of this arithmetic. Maybe many of you did. Let's simplify this out. What's the number I see in that denominator? 13. So it looks like it's stuff divided by 13. What's the number I see in the numerator? Cool. 1 plus 5i over 13. Or if you really, really, really want to put it in the form a plus bi, 1/13 plus 5/13 I.
Neato. How's that idea feel? So if you ever want to divide a complex number by another complex number, step one, multiply and divide by the complex conjugate. Then just FOIL out the numerator, FOIL out the denominator. You'll wind up with a real number in the denominator, and you can distribute. So, is there demand to go through one more example of complex division? Given that I'm definitely asking you to do complex division in the homework. All right, people feel confident? Nice.
All right, then. So, you now know how to do everything that you would do with numbers, with real numbers. You know how to do it also with complex numbers. You know how to add, subtract, multiply, and divide. You can make sense of what the square root of a complex number should be, mostly. There's a weird issue that happens with the plus or minus sign, and when do you choose the plus or the minus? But that's not something we'll get into today. You can exponentiate, you can raise things to a power of a complex number. It takes some effort to make sense of what that should mean. But for now, we'll settle with this. So let's go back to the point of complex numbers. The point of complex numbers is if you believe in complex numbers, you're allowed to have a negative underneath the square root. For instance, if you see the square root of negative 5, well, what is negative 5? It's negative 1 times 5. Square root distributes over multiplication, not addition, but it does over multiplication. So you can write that as square root of negative 1 times the square root of 5. And how would you write that as a complex number? What's the square root of negative 1? Just I. I squared is negative 1, so I is the square root of negative 1. Groovy. Same game. What's the square root of negative 100? I got a 10. But it's not quite just 10, right? 10i. Oh, I guess I times 10 if you want to write it in the same order as the previous line, but it doesn't matter what order you multiply in, so it doesn't matter. Okay, so we're allowed to see negatives under a square root. In the quadratic formula, we sometimes see negatives under the square root, but now we're fine with that. We know that that just results in a complex thing happening. So, let's solve this quadratic equation, accepting that our answers might be complex. And there are options. I think factoring is just going to be out. We could complete the square, or we could use the quadratic formula. I don't know, maybe I'll give you a choice right now. Quadratic formula? Complete the square. All right, so let's use the quadratic formula, see what we get. We will get x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So there's the thing we wind up with. When you simplify the thing under that square root, what do you get? Just this piece. What is that? Yeah. 4 minus 8, also known as minus 4. X equals negative 2 plus or minus square root minus 4 over 2. And what's the square root of minus 4? 2i. Negative 2 plus or minus 2i over 2. Any further simplification that can happen? Yeah, what's the other simplification? Yeah. Everything in the numerator is even, so you can cancel the 2. Does that feel pretty okay? So just because of the feelings during that quiz last time, let's also complete the square, just to do that also. So let's apply the completing the square idea to this same thing. Let's complete the square. 2y equals x squared plus 2x plus 2. So, if you want to use the completing the square idea, the idea is to see something that looks like x squared plus 2bx plus b squared showing up, because that is the same thing as x plus b squared. So, first thing first, I see an x squared. That's good. I would like to see a 2 times b times x. I see a 2x. So what seems like a good choice for b?
1. 2 times 1 is 2.
So it sure looks like b equals 1 should walk. So what's b squared? 1? Yeah, so this will be, I would like to see a plus 1 showing up. And I can. X squared plus 2x plus 1. I can pull a 1 out of that too. That becomes x plus 1 squared plus 1. And remember, we wanted to set this equal to 0.
The whole point of completing the square is now that's something that's easy to solve. You would subtract 1 over to the other side.
X plus 1 squared equals minus 1. So I need to take the square root of both sides now. What's the square root of negative 1? I. X plus 1 equals plus or minus I. And what should I do next if I want to get x on its own? Subtract 1 from both sides. Oh, neat. Does that give the same answer?
Yeah. And I don't know, it took a comparable amount of work to use doing the quadratic formula. If you want big numbers showed up, that's something that's nice. Folks feel okay? So here's the point.
Things like the quadratic formula and completing the square still walk. If you want to solve ax squared plus bx plus c, it has solutions. X equals negative b plus or minus square root b squared minus 4ac all over 2a. And let's think about what sorts of answers we might get. And let's do it by focusing on, the thing underneath the square root.
So we've seen that we might get complex answers. The only way we get a complex answer, though, is if that thing under the square root is negative. If it's positive, we'll get real answers. So here's what we'll do. I'm going to call that bit in orange right there
The discriminant
of this quadratic equation. It's called the discriminant because it discriminates between the types of solutions you see.
So the discriminant of ax squared plus bx plus c is exactly that thing in orange. B squared minus 4ac.
And it tells us everything about the types of solutions you expect.
If this thing in orange, the discriminant is bigger than 0, let's see. If the thing under the square root is bigger than 0, then will that expression be complex, or will it be strictly real? If the thing in orange is positive, can any i's show up? No. If the thing in orange is positive, then the solutions to this thing will be real numbers. I guess here's the other thing. If the thing under that square root is positive, then does it make a difference whether you add or subtract it? Will you get different solutions? Yeah, right, you will. Like 2 plus 7 isn't the same as 2 minus 7. So when the discriminant is positive, you'll get 2 solutions, both of which are real numbers.
And the discriminant tells you that without making you find them.
What if the discriminant is 0?
So let's think about that for a second. If the thing under the square root there is equal to 0, what's the square root of 0? Square root of 0 is 0. Does it matter whether you add or subtract 0 from something? No, right? 5 minus 0 is the same as 5 plus 0. So in the discriminant 0, the two different solutions, the plus or the minus, are they actually different solutions? No. So if the discriminant is 0, then how many solutions does this quadratic equation have? Just the one. And is that solution real or is it non-real? Can there be any i's in it? Just real. If the discriminant is equal to 0, then there is only one solution, and that solution is a real number. In fact, I guess it's negative b over 2a. Fine. Good count. All right, what if the discriminant is negative? If the discriminant is negative, can i's show up in your answer?
Yes.
Yeah. So, the end result, will it be a real number? Nope. So for emphasis, I'm going to put the word non-real there. Right, you might just write it'll be a complex number, but every real number is really a complex number. It just has 0 imaginary bits. So I think that's the most correct thing to write in that space. Will there be one or two solutions? Two, right? It matters whether you add 5i or subtract 5i. The other observation to make is I claim these two things will be conjugates of each other. And let's see why. Well, it looks like I'll see negative b plus a thing times I divided by a real number. The other one will be negative b minus a thing times I divided by a number. Yeah, the imaginary bits are exactly the opposites of each other. So these two numbers will be complex conjugates of each other. Feel pretty okay? Let's play this game. Let's use this result. Let's classify the solutions to there's redundancy in there and I don't like it. Let's classify the natures of the solutions to these things without finding the solutions. And maybe I'll do one. So let's determine how many solutions this thing has. Will they be real or will they be complex? This looks like we just need to compute the discriminant. So let's compute the discriminant of this one. The discriminant is equal to b squared minus 4ac. In this case, that's negative 4 squared minus 4 times a times c. And all I care about is that positive or negative or 0? And if it's obvious, then I should stop. If it's not, then I should keep computing. Can anyone just eyeball that and tell me if it's positive, negative, or 0 without computing it? Negative. Can you say like 2 sentences about why?
Because there's the sign of
Yeah, there's the subtraction sign, and I guess 4 times 3 times 2 should be equal to 4 times 4. It should be like 4 times 6. So you can shortcut some computations. Get that this will be less than 0. You can also just compute it. It's not that much work. 16 minus 4 times 3 is 12 times 2 is 24. All right, so the discriminant is negative. What does that tell you about the solutions? How many solutions will there be? 2. Will they be real? They will not be real. So the pedant in me dislikes how I wound up writing this. But I guess I should address the prompt as written. This has 2 solutions, and those 2 solutions are complex numbers. Feel pretty good? Nice. You think you can complete the remaining plots? Address the remaining plots? Yeah. I think I'm going to pause for a second.
You have folks around you with whom you can walk. Yeah, so change the second one to the thing that I changed it on the screen. That was a mistake on my part when I made this, and I thought I fixed that, but apparently I didn't before I hit find. And you all can discuss with each other. Neato. So let's come together. That second one. Discriminant is positive or negative? And you're negative. Does that agree? Cool. Should I actually go through the computation of the discriminant? Nope. Did you say yes? Do plug it in? Okay. Discriminant is less than 0. So what conclusion do you make? Two non-real solutions. Which is the more correct thing to say than complex, because every real number is also a complex number. But if you say it's a complex number, chances are people will infer that you mean a non-real complex number. Neato. So like on homework, I'd be perfectly happy if you were complex. Next one. Discriminant, positive or negative? Or 0. 0. So what conclusion do you make? All right, and that last one. I hear a one real solution. Does that agree? What did other people get? So it looks like there is some controversy about the value of the discriminant. Should we go through it? Okay, then let us go through it. Let's compute the discriminant. I suspect the issue is just a negative sign got lost. B squared minus 4AC. All right, so go through this problem. What is B squared equal to? 16. Minus 4 times, what is A equal to? What is C equal to?
positive or negative?
Oops.
Positive 42. But if you don't care exactly what it is, which we don't, you can see that it's positive without knowing that it's 42. Neato. So now I'll come together. 1 or 2 real solutions? 2. Excellent. Groovy.
Nice. And maybe just for the sake of emphasizing that on things like homework, there's no reason to have a wrong answer. Let's think about this graphically. If we want to see a graph, could you tell me how many solutions there are? Yeah. So on things like homeworks, even if you do compute the discriminant, x squared minus 4x minus 4, right, like it has 2 places where it crosses the x-axis? Nice. So we've got a small number of minutes left. The homework posted for today is one which is intended to wax a little bit abstract, in that I'm going to have you do complex division in the abstract. So let's maybe discuss the homework a little bit. We have time, and hopefully people are motivated to think about this. The open-ended homework for today asks something of the following form. Let's get a formula for that in terms of A and B and C and D. Say again?
C minus di.
Multiply and divide by C minus di. C minus di will be relevant. Let's write that down. So if you want to compute this, there's the thing you need to compute. Is the multiplication in the numerator easy to do, if maybe slightly time-consuming? Yeah, I think you'll wind up with some stuff plus some stuff times I. Could you expand out the denominator also? Yeah, you'll get like a purely real thing that involves some C's and D's. Oh, then could you like, once you had it in that form, could you get something in the form a number plus a number times I? Yeah. So there's an outline of the idea of today's open-ended homework, which hopefully you'll find helpful when you go and do it. Oh, yeah, so people trickle out. These notes are the notes which we will turn in on next time. If you didn't grab some already, you should grab some now, because as a reminder, campus closes at 3 p.m. today. Unless the chancellor sent out an all-recent email. Yep. Okay. And it stays closed all of Thursday, opening up on Friday. So far. If things change, then things will change. But, so class will be online tomorrow. But that's what we'll be going through, so you may as well grab a copy of it now. Yeah, thank you.